All right, class, welcome back to statistics class. How are we all doing today? Awesome. So today we're going to be learning about significance testing. Before we do that, can anyone help me out and recap what we went over last class? Awesome. Yes, we learned how to check for normal distributions. We learned how to take samples without bias. And we also learned how to calculate statistics and probabilities. So today we're going to learn about significance testing. So what this means or how it can be used, we're checking a hypothesis or a claim and testing whether the claim holds up or whether it can be whether the claim can be proven false or not. And we're going to do a fun project where we are taking M&Ms. The company Mars Inc. has a claim that each bag of M&Ms has 20% blue M&Ms. So we're going to actually test that claim and see if we can prove that wrong. So what's this project going to look like? The question everyone wants to know. So I'm going to go through a little graphic organizer and a template that we're all going to be able to use. This is available in Canvas. So let's all open up our devices and take a look there and follow along. I'm going to project my screen so we are all on the same page. All right, class. So a little project roadmap. Hopefully we're all in Canvas right now, taking a look at this. This is going to be a guideline or a template for what we're going to turn in with our project. So we said that Mars Inc. is stating that 20% of the M&Ms in each bag are blue. So that is our claim here, what we would call a null hypothesis. So this is the hypothesis that we want to test or see if we can prove that it is wrong. Our alternative hypothesis here is what we want to test or maybe what we're led to believe. We think here that less than 20% of the M&Ms in a bag are blue. So that's step one. We're identifying and stating our different hypotheses and claims here. Step two is going to be our data collection. So building on what we learned last class, we're going to sample some data and calculate some simple averages here. We're going to count the number of blue M&Ms. Each of us is going to be given one bag. And then all 36 of us are going to calculate the percentage of blue M&Ms in the bag, and we're going to write it up on the board. From there, we're going to use our 36 data points to check some conditions. Part 3, we're going to calculate sorry, I skipped a step here. So part 3, we're checking our conditions, whether our test is biased or not, and whether it meets our different criteria. So we want to check our sample size, see that that's large enough. We want to check for randomization to make sure that we're drawing randomly here. There's no bias. And we also want to make sure that our samples are independent. So one sample doesn't affect the probability of another sample. Then for part 4, we're going to calculate some statistics, our sample mean, standard deviation, standard error, z-score, and p-value. We'll go over an example of these. And lastly, step 5, we are going to make a decision. So we're going to use our statistics that we calculated, and we're going to compare them to our significance level of 5% in order to come to a conclusion here. Also in Canvas is a graphic organizer that's really helpful in drawing our conclusion. These can get pretty wordy, so this is helpful to organize ourselves. If our p-value is less or greater, and we keep it in that order, then our significance level, we reject or fail to reject the null hypothesis. So going over each case, if our p-value is less than our significance level, we reject the null hypothesis. And if our p-value is greater than our significance level, we fail to reject the null hypothesis. Awesome. Do we have any questions at this point in time? Awesome. So let's move into an example here. So we're going to go through these step by step. Step 1 is to state our claims. So we remember, what's our null hypothesis? That's our hypothesis the company is given, the thing that we want to test. So Mars Inc. said that M&M bags contain an average of 20% blue. So our null hypothesis is that 20% of the M&Ms are blue. So that would mean our population mean, or mu, our signal here, is 0.2 or 20%. And our alternative hypothesis, our hunch that we want to check, is that M&M bags have less than 20% blue. So that would be our mu, or population mean, is less than 0.2. So we're going to get into population and sample mean here. Let's all do ourselves a favor and write out the full 2 words of population mean as well as our mu symbol. These are really easy to get mixed up. So we want to double check this, make sure we're not switching them up, which would lead to problems. All right, step 2, we're going to be collecting our data. So right now I'll be handing each person out a bag of M&Ms. Let's take them all out, count the total number, and then the number blue. So in our student example here, the student's bag contained 3 blue out of 10 total M&Ms. We're going to calculate a percentage blue out by taking the number of blue divided by the total. This is going to lead to 30%. So at this point, let's all share this data on our whiteboard. So there should be 36 observations of what percentage blue we observed. Okay, awesome. Now that we have all that data up on the board, can anyone remind me how we calculate sample mean? Awesome. So our sample mean is the sum of all of the items that we observe. So here, this is all of our percentages of blue over our number of items in the sample minus 1 for our degree of freedom. So we have 36 observations here. So 35 will be in the numerator. Next, can anyone remind me how to calculate standard deviation? Yes, exactly. So it is the square root of the sum of our observed minus our average value squared all over n minus 1. And we take the square root of this. This is a big formula, but it's important. So good to review. So now let's take a moment, class, and everyone use this data, collect it, and we will use it to calculate our sample mean. All right, so we got a sample mean of 0.18 and a standard deviation of 0.14 here. Awesome. So step 3, we are going to check our conditions. So what's our first condition? Yes, for sampling, we need to have randomizations, or we need to have the samples drawn randomly. So we did this because I just handed out the bags of M&Ms blindly. It was completely random. Then, was this independent? Is each person's probability of how many, or the percentage of blue M&Ms the same? Are they related to each other bag by bag? No, each bag is completely independent. And lastly, our sample size. So what was our sample size? We had how many bags of M&Ms throughout the class? 36, exactly. So we learned from our central limit theorem, we have to have at least 30. 36 is greater than 30, so we do have a large enough sample size, and we can assume our sampling is approximately normal. Step 4. So we're going to calculate our statistics here. So our first step, we need to calculate standard error. Standard error is the standard deviation, which we calculated above, all divided by the square root of the sample size, which we also talked about above. So we have 0.14, our standard deviation, over the square root of 36. 36 was our sample size. This yields 0.233 as our standard error. Then we calculate our z-statistic. So what is this z-statistic? It's our sample mean minus our population mean all over the standard error. So plugging these in, we already have all of these things from our formula. We have 0.18, our sample mean, minus our population mean of 0.2, all over 0.233. And we get a z-score then of negative 0.0858. Okay, so flipping onto Canvas as well, there's a link for a z-chart. We'll use this to find our p-value. So let's all open that. I'm going to scroll to it here. We said our z-value was 0.0858. We look up here, we go it's between 0.08 and 0.09. So we'll call it about 0.46. Oops, we're way down here. Sorry, class. There's an exact number, but we can call it about 0.46 here. That is our p-value. Then we state the result. So we said earlier we're using a significance level of 5%. Our alpha is 0.05. And we're going to use our graphic organizer that we talked about earlier for stating our sentences. So our p-value is greater than or smaller than, less than our alpha or significance level. Yes, it's greater than our significance level. So from our graphic organizer, we see we fail to reject the null hypothesis. And that brings us to our conclusion. Do we have any questions before we start this on our own? Awesome. Thank you very much, class. Good luck, and let me know if you have any questions.